Okay, so this video is based on the area of a triangle when it's based around coordinate geometry. As you can see up here, there's actually 3 different formulae that you can use for the area of a triangle. The first one is one we're probably all used to, half the base by the perpendicular height. So you need to have the base and the perpendicular height for this one to work. The second formula is mainly used in trigonometry. So it is a half AB sine C. Now in this case, you need to have one side, another side, and the angle in between. That's what you need to find the area of a triangle in this formula. This is the third formula we're going to be using, and this is the one in particular that we're going to focus on in this video. So it is a half multiplied by x1 by y2, take away x2 multiplied by y1. And this works when you have the 3 points or the 3 vertex of a triangle. So when we're trying to work out the area of a triangle, there's 2 separate cases, and this is the first case. It's when one of the corners of the triangle, or the vertex, or one particular point of the triangle is on the origin. Our second case is when none of the vertex of the triangle are on the origin. All we need to do in this case is to actually just move the triangle so one of the points is now on the origin. So if I focus on this point here, 3, 3, what I want to do is move this point so that it now goes down onto the origin. And now we have 2 new values for the other points. If I go back to my original position, we have this point is 3, 3, this point is 6, 6, and this point here is 9, 4. I want this point, 3, 3, to become the origin. So I want to move it down to where the origin is. But these other 2 points have to translate at the same rate. So they have to move in the same context. So what I want you to do is just look at the numbers here for 3, 3. I want that to become 0, 0. So what I'm going to do is take away 3 from the x coordinate and take away 3 from the y coordinate. So 3, 3 now becomes 0, 0. But the same translation happens for this point up here and this point here. So this point is 6, 6. That moves through the same translation, so it goes down 3 on the x and it goes down 3 on the y, which should get us to 3, 3. And this point over here, it does the same translation. It goes down 3 in the x and it goes down 3 on the y. So this point should become 6, 1. If I move my triangle back down to here, where one of the points is on the origin, we have 0, 0, we have 3, 3, and we have 6, 1, which is exactly as I predicted. Now that one of the points is on the origin, I'm now actually back to case 1, where I can use this point and this point, put those into the area of a triangle formula, and that will work it out for us. Here's an example for case 1. So it says, find the area of a triangle with the vertices 0, 0, 2, 1, and 3, 4. So we know it's case 1 because one of the points is 0, 0. Again, we have our steps on the side, so the first step is write down the formula. So we have area equals half x1 y2 minus x2 y1. Our second step is to label the points. Now because 0, 0 is one of our points, we can ignore that one, so we're going to be focusing on 2, 1 and 3, 4. I'm going to say this point is x1 y1. I'm going to say this point is x2 y2. Now on to step number 3, we insert the numbers into the formula. And again, as I've done in previous videos, I'm going to fill out the formula, but I'm going to put in brackets for the variables at the start, just so we know where each one goes. So this bracket here is going to be x1, this bracket here is going to be y2, this bracket is x2, and this bracket is y1. Now it's time to put the correct numbers in. So x1 is going to be 2, so 2 goes into this point. y2 is going to be this number, so 4 goes in here. This bracket is for x2, so x2 is the number 3. And the last bracket is for y1, which is 1. So I'll put a 1 in here. Now as you can see, we've got 3 steps done already, so it's now time to evaluate the whole question. A for area equals a half 2 times 4 minus 3 times 1. You don't have to write this line if you don't want to, but I like just to write it out all in one colour. We get a half. 2 times 4 is 8 minus 3 times 1 is 3. Close the bracket. So we have a half 5, which is 2.5 units squared. Or we could say 5 over 2 units squared. This question says a triangle has vertices of 1, 2, 4, 6 and 6, 8. find its area. We know this is case 2 because none of the points are the origin or none of them are 0, 0, which is the same thing. We have our steps here on the right hand side, but the only difference, I've added an extra step at the start which takes into account the fact that this is actually case 2 and not case 1. So we have to translate all of the 3 points. I need to choose which point I'm going to use to the origin. So just for the sake of it, I'm going to use this one because it's the closest. I'm going to write down my 3 points here again. And I want this one to become 0, 0. So to get 1, 2 to become 0, 0, I need to take away 1 from the x coordinate and I need to take away 2 from the y coordinate. And I need to repeat this translation for both of the other points. So -1, -2, and -1, -2. That gives us new coordinates of 3, 4, and 5, 6. I've now completed my translation, so go on to the second step. The rest of these steps are the exact same steps as what we've had in case 1. So I'll write down the formula. Area equals a half x1 y2 minus x2 y1. I'm going to label the points. I can ignore 0, 0. My first coordinate is going to be x1, y1, and my second one is x2, y2. My third step is fill the numbers into the formula. Again, using the green line like I did in the previous section. So we have a equals a half x1, y2 minus x2, y1, and the end modulus. Now I put the correct numbers in. This bracket is going to be x1, which is going to be 3. y2 for here is going to be 6. x2 for here is going to be 5. And y1 for here is going to be 4. And our final step is to evaluate. So a equals a half modulus 3 by 6 is 18. Take away 5 by 4 is 20. This gives us a half times -2. Because this is -2, if I just found a half of -2, that would give me -1. Now we cannot have a negative area. That doesn't make sense. How can you take up negative space? These modulus bars fix that problem. So what they do, whatever you have on the inside, it just makes it positive. So if this was a 7, it would stay as 7. But because it's -2, it becomes +2, which is just 2. So now we're finding a half of 2, which is 1 unit. So that completes this video on the area of your triangle formula. Hopefully it helps, and I hope you now understand what the difference is between the case 1 and case 2 and how to use the formula correctly.